Chapter 14, Kinetics, Exercise 14.57. We have three graphs, A versus T, ln A versus T, and finally 1 over A versus T. The first graph tells us it's not a zeroth order reaction because for a zeroth order reaction, A is linear with T. The second graph tells us it's a first order reaction because for first order reactions, the natural logarithm of A is linear with T, and this graph looks perfectly linear. The third graph tells us it's not a second order reaction because for second order reactions, the reciprocal of A should be linear with time, and it's not. Therefore, this is a first order reaction for sure. Not zeroth, not second, first. And then what's the value of K for the reaction? The value of K for the reaction can be obtained from this graph. ln A is linear with time, and we can determine the slope here, and the rate constant is negative slope. So how do we get the slope? Very simple. You can look at the change here from negative 2.3 to negative 4.3. So the difference is negative 2 divided by 200. So the slope is negative 2 divided by 200. It's negative 0.01. And the slope is negative slope. And the slope is negative. So we have negative 0.01 as the rate constant. That's just my estimate. By the way, I think Mastering Chemistry used the data at 150 seconds. I used the data at 200 seconds. It feels easier this way. Alright, first you just need to divide the change of ln A by 200. And 2, I think this is roughly negative 2.3, and this is roughly negative 4.3. The difference is simply just negative 2. And then divided by 200, and then multiplied by negative 1. So I think that's easier. Of course, you can look at the data at 150 seconds. It's just a bit more calculation. Part C, what's the rate law for this reaction? This is easy. The rate is K times A to the power of 1. That's it. Let me see if I can put 1 in the superscript here. Oh, alright, so it's accepted. Also, you can just write Ka.